Acoustic performance of walls. Studs. C&I section cold-formed steel studs are used as vertical elements in walls. Typical profiles are shown in the figure on the right. Sections are available in a range of widths, lengths and thicknesses depending on requirements for strength, height, impact resistance and sound insulation. Typical dimensions of a section are 70 to 100 mm deep and 0.9 to 1.6 mm thick. Light steel stud walls can be load-bearing or non-load-bearing. Wall linings. There are many different types of gypsum-based boards which have been developed to have different properties suitable for different purposes. Gypsum-based boards fall into two main categories. Plasterboards. Fiber-reinforced boards. Gypsum-based boards are suitable for lining light steel frame walls, partitions and also ceilings. Resilient bars. Resilient bars can be used to increase the sound insulation by absorbing vibrations. These bars may be fixed between the light steel wall studs and the wall linings. Resilient bars are manufactured from light gauge steel, typically half a millimeter thick. The sections are typically 16 mm deep. Separating walls. The following wall constructions are presented. Twin light steel frames, insulation between frames. Twin light steel frames, insulation between studs. Twin light steel frames for modular construction. Single acoustic stud light steel frame. Single light steel frame with resilient bars. Staggered stud light steel frame. Twin light steel frames, quilt between frames. Twin light steel frames, quilt between studs. Twin light steel frames for modular construction. Single acoustic stud light steel frame. Single light steel frame with resilient bars. Staggered stud light steel frame. Internal walls. The following wall constructions are presented. Single light steel frame, with quilt. Single light steel frame, without quilt. Single acoustic stud light steel frame, with quilt. Single acoustic stud light steel frame, without quilt. Internal wall construction details reference. External walls. For masonry walls, such as a 225 mm solid brick wall, a brick and block cavity wall or a brick-clad stud frame wall, timber or light gauge steel, the sound insulation performance of the facade will normally be such that the doors, windows, ventilators and, in some cases, the roof will dictate the overall sound insulation of the building envelope. The exact acoustic performance of the external wall system is dependent on the specification of the products used. Where higher levels of acoustic insulation are required, the internal plasterboard lining can be upgraded, example, by using sound insulating boards rather standard wall board or by increasing the number of layers. Acoustic performance of floors. Composite floor on steel beam. A composite floor slab consisting of in situ normal weight concrete and steel decking supported on steel beams. The steel beams may be below the composite slab, as shown, or integrated into the depth of the slab. The decking may be shallow or deep, ray entrant or trapezoidal. Typically, the concrete thickness is at least 80 mm at the shallowest point and at least 130 mm at the deepest point. Precast units on steel beams. Precast hollow core concrete units supported on steel beams. The precast units should be at least 150 mm thick and weigh at least 300 kg/m2. The joints between adjacent precast units and voids around columns should be filled with grout. Light steel joists with boards. Light steel joists at 400 to 600 mm centers. The light steel joists are generally 150 to 250 mm deep C-sections. A decking board is fixed to the top of the joists. The decking board may be chipboard or plywood. Deep batten floor. The floor treatment consists of tongue and groove flooring board at least 18 mm thick. Resilient composite battens at least 70 mm deep. The timber batten is bonded to resilient foam strips that may be at the top or at the bottom. Cradle and batten floor. The floor treatment consists of tongue and groove flooring board at least 18 mm thick. Resilient cradle and batten system at least 60 mm deep. Timber battens are supported on cradles and resilient pads. Standard batten floor. The floor treatment consists of tongue and groove flooring board at least 18 mm thick, resilient composite standard battens at least 45 mm deep. The timber batten is bonded to resilient foam strips which may be at the top or at the bottom. Platform floor, timber board. The floor treatment consists of tongue and groove timber flooring board at least 18 mm thick, mineral wool resilient layer at least 25 mm thick. Platform floor, gypsum fiber board. The floor treatment consists of 2 layers of gypsum fiber board, each layer at least 10 mm thick. Mineral wool resilient layer at least 10 mm and approximately, or compressed wood fiber at least 10 mm and approximately. Sand and cement screed floor. The floor treatment consists of sand cement screed, typically 60 to 80 mm thick. An isolating layer comprised of dense mineral wool and waterproof membrane carefully installed to ensure continuity. Lightweight screed floor. The floor treatment consists of gypsum-based lightweight screed, typically 40 to 70 mm thick. An isolating layer comprised of dense mineral wool and waterproof membrane carefully installed to ensure continuity. Acoustic performance of ceilings. Typically, separating floors should have a ceiling treatment of at least 1 layer of gypsum-based board. Composite separating floors and precast unit separating floors use a suspended ceiling that is not connected directly to the structural floor but is supported from it. The ceiling treatment options for composite and precast separating floors are shown in the following section and figures. For light steel separating floors, the ceiling board is generally supported directly by the structural floor. For composite separating floors and precast unit separating floors where only 1 layer of ceiling board and no insulation in the ceiling void is specified, the sound insulation performance of a ceiling treatment can be increased by placing a mineral wool quilt in the ceiling void or by using 2 layers of gypsum-based board. Including mineral wool quilt in the ceiling void can improve performance by 3 to 4 decibels for airborne and 4 to 5 decibels for impact tests. Acoustic ceilings construction details. Acoustic ceiling and floor construction details. Odeon software. Odeon is the most comprehensive software for room acoustics. Use the Odeon software for simulating and measuring the interior acoustics of buildings. With the appropriate treatment, outdoor situations can be studied as well. Given a 3D model and materials, surface properties, the acoustics can be predicted, illustrated and listened to. Sound reinforcement is easily integrated into the acoustic predictions. Odeon uses the image source method combined with a modified ray tracing algorithm. Odeon is known for its easy workflow, fast calculation times and high accuracy. The easy workflow makes it fast to begin using for the most common tasks. The fast calculation time makes iterative design processes possible, and the high accuracy makes it trusted by a large community of engineers worldwide. What can you do in Odeon? In Odeon you can work with room acoustics in an almost endless number of ways, depending on your purpose. The most common would be, make simulations of acoustics from 3D models, and display them in numerous ways. Measure the acoustics in real rooms, and get a range of results immediately. Listen to the acoustics of 3D computer models with the auralization options. For what type of rooms? Odeon can be used for medium-sized rooms and larger. Concert and opera halls, theaters, churches and mosques, open-plan offices, foyers, restaurants, music studios, underground and railway stations, airport terminals, industrial environments, small-scale outdoor areas, up to 2 kilometers in each dimension. Workflow. When working in Odeon, the design process can be iterative, trial and error, trying out different materials, sound sources, result options, parameters, etc. This is possible because of the fast calculations based on the strong algorithms of the software. See the flowchart of the workflow of simulations in Odeon on the image. However, when working with measurements or other applications, the workflow will be different. Import 3D geometries. Measure the acoustics in a 3D computer model. Imported models can come from a range of different software like SketchUp, Rhino, AutoCAD, etc. Measure real rooms. You can not only simulate, but also measure real room acoustics with an accurate sweep method system. The sweep method attenuates the background noise drastically, making it much better able to get good results. Acoustics in graphs. The acoustics can be displayed in easy-to-read graphs, where you can toggle between parameters and octave bands. Acoustics in numbers. In Odeon you get a huge range of different acoustic parameters calculated by default. You can even define your own parameters. Acoustics in color maps. The best tool for an overview of the acoustics of a room or space is the color maps, or color grids. Get the acoustical parameters displayed over surfaces, and thereby get a very precise picture of how the geometry affects the acoustics. Acoustic surface properties. For all surfaces in the model of a room or other geometry, you can enter the acoustic properties. Choose absorption coefficients from our large library of materials, or set your own values. Additionally, you can set scattering coefficients, transparency and reduction/transmission index for all surfaces. Listen to oralizations. Acoustics are about sound, and in Odeon you can get to listen to the acoustics in the model. Choose from speech, instruments, or other audio files, and listen to how it would sound at the location you choose in your model. This can also be a good way of presenting acoustics to people not familiar with acoustic parameters. STI. The Speech Transmission Index, STI, combined with the color grids can be a powerful way to showcase how acoustical treatments can change speech intelligibility at different locations. Many types of sound sources. Set up loudspeakers, human voice, omnidirectional and other sound sources in the simulations. Choose between point sources for specific positions, a line source for pipes, trains or traffic and surface sources for example, machinery. Compare measurements and simulations. As you can both measure and simulate the acoustics in Odeon, it has been made possible to easily compare the two. This can also be done with measurements made in another way or with another software. This is good for validating your model when working with acoustical optimization projects in existing rooms. Reflector coverage. If working with reflectors, the reflector coverage option in Odeon is very convenient. See how the position and angles of the reflectors will distribute the sound.